Hey crew, so I need to talk to you about how to do the lab, just so you have a visual and a verbal for it. So when you start out, you're going to set up your cup. So there will be 15 individuals that are homozygous dominant, so AA. There'll be 30 individuals that are heterozygous, so AS. And there's 15 individuals that are SS or homozygous recessive. That means there will be 60 red beads and 60 white beads. I'm doing this based on the cup that I gave you. So if you're using something else, it's probably not going to be red and white, but just do 60 of each of your two variations, whatever it is you're doing. So there's 3 different simulations we're going to do. The first simulation, all of your individuals are going to survive. So you're going to draw 2 beads at a time, so pull 2 of the beads out of the cup, and you're going to look at them. If you have 2 red beads, that's going to be an AA, and you'll put a tally in that section. If you pull it out and there's 1 red and 1 white, that would be AS, and so you put a tally in that section. If you pulled it out and you had 2 white ones, then it would be SS. Now here's the big part that you need to remember. You must put the 2 beads you just pulled back into the cup. Take them out, look at what they are, make the tally, and put them back in the cup every single time. And you'll continue drawing 2 beads at a time until you get to 60 tally marks or 60 individuals. So we're going to do 5 just as an example. So we pull it out for our first offspring. We have a red and a white, so that's AS. So we put our little tally, and then we put them back. We pull our second offspring. It's 2 red beads, so that's AA. We put the tally mark, so then we put it back. The third individual, we pull it out. It's 2 red beads, so AA, put a tally, and then we're going to put it back. Fourth offspring, it's 2 white ones, so SS, put a tally, then put it back. And then fifth offspring, we're going to have a white one and a red one, so that makes it AS, put our tally, and then we will put it back, okay? So for your math, you'll fill your tallies in. You'll count the number of individuals. So, for example, we had 2 that were AA, 2 that were AS, and 1 that was SS. For you, yours is going to total to be 60, but since I did our little small demo of just 5, mine's going to only equal 5. We then take the genotypic frequency. We take the number of individuals divided by the total number of individuals. So 2 divided by 5 gave me 0.4. 2 divided by 5 gave me 0.4. And 1 divided by 5 gave me 0.2. So then we're going to continue on trying to figure out the number of alleles. So to determine the number of dominant alleles, or A allele, we'll take the number that are homozygous dominant, or having 2 of the A alleles, and multiply that by 2. We then take the number that are heterozygous and multiply by 1. That will tell me the number that are dominant. We do the same thing for our S's, and then we divide by the total. Now yours should say 120 because you have 60 individuals that each have 2 alleles. So yours would be 120, but since I only did 5, mine is 10. Then we take the number of individuals, divide by the total. 6 divided by 10 gives you 0.6. 4 divided by 10 gives you 0.4. So that's our simulation 1. Simulation 2, we're going to then set everything back up, have 60 red, 60 white. Problem is now SS has sickle cell and it will die. It does not have appropriate health care and will die. So the same thing, you take 2 red ones out, you have an AA, take 1 red, 1 white, it'll be AS. If you pull out 2 white beads, it is dead. Do not record, but you must put it back. You will still continue to do your pulls until you get to 60 individuals. Okay, so practice it out. 2 reds, AA, put the line, put it back. Second individual, AS, put the tally, put it back. Third individual is 2 whites, so it's SS, it's dead, so we put it back. Third again, 2 whites, SS, put it back. Until we try again, we finally get 1 red and 1 white, and that's going to end up being our AS, so we put the tally. And then we do the exact same math that we did before. Yes, I expect that bottom row to be completed. You should have 0 individuals in that bottom row. I actually try to put something on the chart in the activity so you don't accidentally write in there, okay? Do the same math we saw before. Now here's where problem comes into play. We need to see what happens over time. So we just did 1 round. We now need to do a second round. So you need to reset up your container to match the beads that are in after the first generation. And so you'll take however many we have in this column that has A and S. You'll take that number and make that match whatever's in your cup, okay? And so you'll adjust the parent population to match your generation. So the example we had here was I would have 4 reds and I would have 2 whites in my cup. Yours is still going to end up being 120 beads, so you may have 80 reds and 40 whites. It all depends on how you pulled and what you got from your table and what you did your calculations. So we do the exact same thing, we do the math again. So simulation 3, now the red one, I'm sorry, if we have homozygous recessive, they die still. But now if I have homozygous dominant, then there's a 50% chance of living. And so you have to find some way to keep track of this. Again, you still want to get to 60 individuals. So first offspring, pull it out. 2 reds, it lives, throw it back. Second offspring, heterozygous, throw a tally, put it back. Third offspring, 2 homozygous dominants, it dies because we already had one that lived. So we put it back. Third offspring again, now we have homozygous recessive, it dies, put it back. Third offspring again, 2 dominant alleles, so we put our tally and put it back. Again, only 50% of them live. So you see that offspring number 1, homozygous dominant, survived. Offspring number 3, the first time, did not survive. And then offspring 3 again did survive. Do the same math we looked at before. And then reset up your container. And that is it. I hope that was helpful.